a week ago we discussed loops, and you guys had well, several exercises on that. You had several things to play with, and I think the main exercises you did well. And I wanted to talk a little bit more about the different implementations and introduce one more thing related to loops. So we discussed the for loops last time, and of course, with a thing like Fibonacci's numbers, Fibonacci sequence, or the factorial, you can certainly do it with the for loops. However, you can implement these things alternatively in Python and in other programming languages, and I wanted to show you an example of that. So let's say we start from, well, I would start from the Fibonacci sequence, and so we start from reading an input, right? And I will call my variable imp, and then ask a user to enter a number. Enter a number. All right. I need to save my file, otherwise it's not going to be executing. I'll call it 0 to Fibonacci. Okay. So this for now, it will be just asking for a number, and then I will convert my input. I will convert my input to an integer. And let me do one more thing. I want it to be a little bit larger so that you can see it better. Okay. All right. So, and then as the Fibonacci's number are defined, you can have two variables and introduce this one and this one, which will be the Fibonacci's number minus n and the Fibonacci's number minus 2 and minus 1. And then the entire sequence can be calculated using one for loop. So for I in a range of n, where n would be this number till I need my calculations to be done, I will do the current Fibonacci's number is obtained from the previous one and the one before it, right? So then I can just print it, right? And after that, I need to reassign them. So the number with an index n-2 became, well, basically I proceed one step further. So the one which used to be phi minus 2, it becomes phi minus 1. So this one becomes the current one. And I can run my code, enter the number, and let's start from this, for example, 5, and it will give me my sequence, right? And I can run it again and try doing something else. Say, oops, sorry. Let's say I can enter 20 here, and it will give me my sequence of the first 20 Fibonacci's numbers, right? So that's one way to do it. And oh, and by the way, last time we discussed that it's better to, when you write a Python script or any other code, it's better to assume that the user of your code will be not very smart, and this user can enter something which is different from your expectations. So let's say I run this code again and I enter a number. Oh, let me make font a little bit larger here as well. So I enter a number here, which will be 12.3, right? And then, well, 12.3 has problems with being converted to integer here. So the string 12.3 has problems to being converted to integer here. So the entire program, the entire code gave me an error, right? And it didn't work. And you typically, excuse me, you typically don't want to have this sort of issues. So you want to add some if else, check if this is integer to begin with, and so on. Another, well, that's one thing. Another thing, you can implement it differently. And for example, if I initially, the way I formulated the problem is to give the first n Fibonacci's numbers, right? But what if I wanted to not tell the nth number, not to get it not till a certain number, but till I reach a certain, so that the Fibonacci's number reaches a certain value, right? So instead here, well, if I'm running my script and saying, let's say 20, right? It gives me all these numbers up to 10,946. But what if I wanted to have the numbers just up till they exceed 20? There is one thing in loops which we didn't discuss yet and which is quite useful. You can have a condition to break your loop. So you can check if certain condition is fulfilled. You can say, okay, if this is the case, then, you know, break it, break the loop, stop doing it. So, not, I had a typo here. So in order to do that, for example, if I want to check here that if my Fibonacci's number greater than n, right, then I can say break. And this thing will work differently. So if I, let me save my script and rerun it again. Oops. Save it and rerun it. I'm entering a number and I say it's 20. So it goes in the same loop, but it checks when the number exceeds the value we're given. Well, it stops the sequence. It breaks the loop earlier, right? And that's quite often it is useful. However, there is one more way to do it, and in order to do it, you can use a different, well, you can use a different type of loop. So for loop is not the only loop we have. Another one is a while loop, and I will show you how it works using this example of Fibonacci's number. Let me just create a new file and save it as Fibonacci. Let me just call it while. All right, okay. So this is an example of a while loop. Okay. All right. So I'll start. Let me not mess with the input. I just start. Okay. Let my n equals 100. Then I will introduce the two variables phi2 equals 0, phi1 equals 1, and the current Fibonacci number would be also 0. Oops. Okay, and then I want to repeat something in a loop while a certain condition is valid. So while Fibonacci's number phi is less than n, we can print this number, right? And then this condition will be performed while this is while this is true. So let me type here. So after this is performed, after we print this number, we need to go and calculate the next number in the sequence, and this is calculated using the same formula we had before. So we add the two consequent numbers, and then we say that the number which used to be n minus 2, it becomes equal to n minus 1, and the number which was n minus 1 becomes the nth number. And if I do that, yeah, it prints me the sequence of Fibonacci's number until they start exceeding 100, because this is what I specified. If I do it exactly like in the previous example, it will print me the same numbers from 0 to 13, because the next number would be 8 plus 13 will be 21, will be exceeding 20, so the condition for the while will be violated. So that's another loop in Python, which sometimes is quite useful. Any questions so far? Okay, no questions. Then I'm proceeding, because the next thing we're going to discuss today is extremely useful, and without it, I don't know, programming would be not that efficient. Well, I don't know how efficient it would be without loops, but the next thing is a function. And a function, do you guys remember what in math, what a function is? What do we call a function? Does anyone want to remind me? Anyone except Ellie. Ellie, I know Ellie knows, right? Okay, fine, go ahead.
So in this case, a function would be an equation.
Well, no, equation and the function are different things. Why would mathematicians call equations if they're functions?
Is it a set of inputs that has a set of outputs?
Say it again.
It's like a set of inputs with a possible set of outputs.
Well, this is partially true, but there is one thing is missing in order for some rule to be a function. There is one specific thing in math which must be there.
Every one input you get one output, or something like that.
So for every input you can get no more than one output. That's important. But in general, function in math is a certain rule which you have one set of
Parameters?
numbers, right? And you have this rule which gives you another set of numbers using this certain rule. So in programming, it's somewhat similar. Well, with one exception that, first of all, here a function does not necessarily have to return you a certain value. Second, it's not necessarily about numbers at all. A function does not have to be a mathematical function. And well, probably there are more differences, but let me show you some example, and I'll use the console first. And Brian, you had some question, or you wanted to add something?
No, I thought you were going to say you need parameters for a function.
Oh yeah, that's for sure. Well, you need some input, right? So in Python, if we start, so the syntax is the following: you use the word def, which stands for definition, and then you enter a name, and the name of your function, it could be anything. You can name it the way you want, except a certain names which are protected in Python. So let's say it's my function, and it can has one input, right? And it can do something, right? For example, if I want, I can define a function which will be just printing my variable, right? And I press Shift Enter, and then I want to call my function, right? In order to call it, I type the name of my function without the word def, and I feed a certain argument there, right? Certain value for my argument, and it will do exactly what it does. All right, I introduced a function which just prints what I feed into it. Well, there is no need to introduce it because this function is already available in Python, and this is the function print. So, well, here although I'm illustrating an example of functions, but I'm not introducing any function which would be useful. Well, what I can do, on the other hand, I can introduce a function. Let me call it my function. Let me call it my multiplication, right? And it will take 2 arguments, right? And then what this function will do, it will print a product of these 2 arguments, right? And then now if I call my multiplication and come up with 2 numbers, right? 2 and let's say 3, right? It will print me the result, right? So this function, it's interesting, this function is printing the output, but it's not returning the output. You can have a function which returns a certain value to you, and this is especially, well, in engineering and math, this is especially useful. We don't need functions which just print something. We often need functions which return us some values. So I can introduce the same function. Let me call it my multiplication 2. So it will have the 2 variables for the input. And then it will, what it will do, let's say, return the keyword for the function, return x multiplied y. And that's another function. If I now call my multiplication 2 of the same arguments, 2 and 3. So it didn't print me anything. So the Python shows the results of the output because it returns certain thing. It returns the product, but it doesn't print it. So I can, if I want, of course, it makes sense when we introduce in function to introduce many different operations in there so that it will do several things within these functions. So for example, I can introduce my multiplication 3 x y, and I will ask this to I will introduce a variable result, or let me call it a product. Okay, product equals x times y, and I can ask this function to print the product, and I can ask this function also to return the product. So it will do both. And now if I do my multiplication 3x, I need to give it some values, 2, 3, it will not only calculate the result for me, it will print it. So obviously, well, we can use functions for pretty much any pieces of code which we're repeating. For example, it makes total sense when we deal with our Fibonacci's numbers. It makes total sense to introduce a function which returns, well, either the nth Fibonacci's number, or it returns the entire sequence of Fibonacci's number. So which will be quite convenient if we want to call this piece of code many times. And we can certainly we can certainly do that. You know what? I'll pause the recording. All right. So here's how I would do it. I called my function my factorial. So I introduced the definition of my factorial, which takes exactly one variable as an input, and return the variable which I called fact, which is the factorial. And then inside I have this just for loop. And then after I introduce my function, well, if I do just that, if I remove this line and run it, my code does something. It introduces this function, but it doesn't execute this function. In order to call the function, you need to call it, right? I can just call it. I don't have to print it. I can say, okay, I want to calculate a factorial of 5. It does something, but it doesn't show the output. If I want to see the output, I should rather print it. So I can say print, and then print the output of this function. And then it gives me 120. If I change 5 to something else, to 10, it will give me a factorial of 10 instead.
Professor?
Yes.
Do we have to use a for loop?
You don't have to use a for loop. Well, you can use other loops. It's you can, and I wanted to show you an implementation where you in fact don't use loop at all. And there is a way to calculate the factorial without loop, and it is called recursion. So the function within the function, you can call another function, right? So for example, if I could have called I don't know, I could have, when I do my function my factorial, I could call the function print, and it would print me something, and for example print my factorial, right? And then I would just need to call this function, and it will do the same. Oops, sorry. Oh, because I need to do it before I return. Once I have return, it exits the function. So I need to do print before that, and I'm doing print inside the function. So if you can call a function inside the function, well, you can actually call the function itself inside a function. So this loop is called a recursion, and it's quite frequently used in programming. Let me show what specifically I mean, and let me create a new script. Call it 0, 3 factorial recursion. Oops, recursion .py, and let me introduce. Oops, need to my fact recursion. I could have done it in the same script. I don't need to create a new script for every new function, but well, I've done that. That's fine. And it will be exactly the same syntax in terms of it has one input variable, but then in the function itself, what I want to check that n is not equal to 0. If it's equals to 0, well, I return the value of 1, right? The factorial of 0 is 1. However, if it's not equals to 0, then I can calculate a factorial of n by taking n and multiplying it by factorial n minus 1. Then n minus 1 is calculated from n plus 1, etc., etc. So I return in this case n times the factorial n minus 1, right? And n minus 1 is calculated using this function. my factorial recursive n minus 1. All right. And now if well, first of all, I can run it. Well, obviously it's not going to print anything because I haven't called my function. But if I call my function now and I print the outputs, let's say print my factorial recursion, and the argument, I'll take the same argument, 10, and run it, well, I get the same number as I had before. So looks like it works. It looks like it does what I want it to do. And this way of calling a function is called recursive. Okay, so one thing I want to show few other things, and then probably I will give you an exercise as a homework assignment. Any questions so far? Any question about recursion, about functions? Okay, excellent. So I have to admit that although, well, it's fun to implement all these simple math functions, all the simple math functions are, of course, implemented. And Python is built with a bunch of modules. And in particular, there is a module which is called math. So in order to use a module, if I just type math, it won't give me anything. I need to import math. If I use import math, it will be using this module where a bunch of mathematical functions are available. So, and if I want to use the functions from math, for example, I just type math factorial, and then give it an argument, and it returns me the same value, right? So the math module already has the factorial. It has different numbers in it. It has e number, it has pi number, and it has I don't know, square root, and so on and so forth. And so in fact, it's, well, basically, if you're working in engineering, you won't survive without using a Python math module. Well, you can, first of all, when I say, hey guys, there is a Python math module, and I assign something as a homework and you need to do to use this module, first thing what I would suggest is just Google for Python math module, and it will give you all the details in it. Alternatively, of course, you can get some help on the math module. It will give me what data it has, it will give all the functions it has, and so on and so forth. And as you see, there are anything what your calculator has, it will give you. So and probably even more. All right. So, well, long story short, luckily we typically don't need to write functions like factorials. We need to worry about functions which are more specific, which do something else for us. Oh, I want once again to emphasize, not to confuse you. I've been talking about math and math functions. A function in Python is not necessarily it's not related to math. So you can, for example, in addition to your definition here of the factorial, you can introduce another function, and let's call it a function greeting. And this function greeting takes one variable as an input, and all it does, it will greet you using your name, right? So if I now call my function greeting, I don't want to call my factorial anymore. I'm gonna call greeting, and let's say, well, Gennady, right? And run it. Well, it will say, hello, Gennady. And well, what I didn't do well, I have extra spaces here, but let's not worry about them right now. But yes, from the point of view of normal syntax, yeah, it looks a little bit weird. But anyway, functions are just these things in Python where you can put many operations all together and call it several times, multiple times, thousands of times within your code, and reuse some piece of code multiple times. All right, any questions? Okay, so what I want to show you, and that's probably the last thing for today, mostly, yeah, we'll do a couple more things, but related to that is, we often work with data, and we need to store our data. We store our data in files. We don't use, yes, in Python so far, we've been using these console, the IPython console, but it's not very, well, it's not very practical, right? You want to, especially if you are doing some calculations, you want to store your data somewhere, or you want to take some data from somewhere, so you have to work with files, and therefore you need to create a file, read file, write to file. Let me start from reading a file, and let me create. Oh, actually, I'm not sure if I can do it from Python. Can I save a file here as a text file? Yes, I can do it as a text file. All right. So I want to save it as data txt. Okay. Yep, it saved it as a text file, and look, it stopped highlighting it because it's a text file, and I want to put something else here. So for example, one, and I want you guys to do the same so that you have the same type of file on your computer. One, one, one. I don't know. Let's be simple. Two, 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 and three, three, three. Oh. And let's say we have this, and that would be my, well, data, whatever data it is. Let it be the coordinates of certain points, and each line corresponds to a new point, and each column corresponds to coordinates of these points. And now I want to read this file, and in Python, it's extremely straightforward. Let me introduce a new script for that, and it's done with I can introduce a file object, so file, using the file name, and how did I call it? I think I called it data txt, right? And I give it an option R, which means reading, right? Oh, okay. Oops. Oh, it doesn't. Okay, I need to import something. Let me quickly look it up. So, okay, yeah, it's open, and I don't need to import anything. I just need to use the right syntax. So I open file, and this R here means that I open it for reading. I'm gonna read the file, not write to it. And then I can introduce a variable, a string variable. Let's call it str. I don't know, or okay, file content equals f read. And after I do it, one thing I need to do, I need to close my file. So this 3 lines will read the entire content of this file, into a variable. So of course, what I can do, I can easily print the file content, and I'm going to do that. And as you can see, it prints exactly what I entered in my file. Please make sure that yours does the same. And well, obviously, it's not fun to just read file and print the content. It's fun to do something with it, but each line in this file is a string, and I want to well, if I want to treat it as numbers, I will have to split it into numbers. And well, there are, first of all, there are functions to deal with, to read the files string by string, and this is what I'm going to be doing. And also there are functions which splits your string into something. So let me first show what would be the alternative way to do it. So if I start my file open, and instead of reading the entire file content in a single variable, what I can do is I can say, well, the file lines or whatever would be this f, and then instead of read, I will use read lines, and it will read all the lines in these file into this variable. And now I can print file lines. And you see, unlike the previous case when it printed me exactly what I had in the file, now it returns me a list of 3 strings. And this first element of this list is the first string in the file, the second element is the second string, and the third is the third. But it's a list, it's a different kind of object with which you can do a lot of operations we've studied before. Do you know what this thing is? Does anyone know what it is? No idea? Okay, that's a new line symbol, and that's something. It's a special symbol used in pretty much any programming languages, which defines the new line. So, so when Python read it, it knows that it has the 3 numbers in it, and then after that, the next character starts from new line. So that's why it have it. And it doesn't have it in the last line because I removed it in the last line. And oh, by the way, if I go back to my file, so data.txt, and add just one enter here, so add one empty line, and then I go back to my code, if I find it. I have too many scripts open. Oh boy. Okay, read file, this one, and I run it again. You see these end line character appeared in the last line as well. So, yep.
When I ran the file, well, the script, it gave me the same thing, but it's also a little different. I have the brackets. You know how your output has the brackets of just the terms. Mine has a bracket of other stuff that probably doesn't belong in the output.
Interesting. So I'm willing to take a look at it. Let me pause the recording. Okay, so let me proceed, and I wanted to say that your example was specifically, I think it's a very nice example of what you want to have in your file when you're reading it and what you don't. So if your file has something at the top, which is a comment, okay, and when I save my data, not only me, it's a common practice. When you save your data, of course, you want your file name to be transparent, so that the user can find what these data mean. But besides that, you typically add comments to these data. So I want to say these are coordinates of 3 points. Okay, prepared by Gennady Gor as an example. All right, so however, when I go here and read my file, well, of course, if I read it, I will get all these stuff right here, which I do not need. I don't need these comments. The comments are needed if you want to look into the file itself, but if you want to extract the data from your file, you don't need it. So we need to modify our script. So let us call a script to read data file ignoring comments. So I do the same. I start from the same thing. I open my file and I want to get to some data, right? Let me introduce an empty list, which I call data. And then I can go in my file line by line, and I'll do it in a for loop. For line in, and then, well, I call it F read lines, right? So for the lines I'm reading, or I can alternatively I can introduce an additional variable which I call read lines, in which I read all the lines, right? But I don't need it. Okay, for a line in F read lines, I want to read each of these lines and make sure this is not a comment. So if not, I need to make sure that this, and we agreed that the comments, similar to Python, starts with this number sign, right? Let me make it a little bit larger, right? So if it starts from the number, then it's a comment. Otherwise, it will be treated as data. Okay, if not line, and then you can look up all the methods and which line has, and in particular, it has a method of starts with. If line starts with number, then well, so this condition helps me to ignore these lines. So if this is not the case, then I can do something with them. Oh, why am I so indented, right? So I introduce my variable split line, which will do the following. It will take my line and split it. And then I want, let's say, well, to begin with, I can do in the loop, I can print each of the lines, okay? I can print each of these split line. Let's try if this is gonna work. Yep. So you see, so far, my script that did the following. So it opened the file. I didn't fill the data in, right? I opened the file, I went in a loop through this file, all the lines which were starting from the number sign were ignored. So the first two lines were ignored, and if I add a comment in the end, it's going to be the same thing, right? This is yet another comment. And I can rerun my script, and it's going to give me the same output. So all these comments were ignored. Then each of the lines were split into lists, right? And I'm printing each of these lists separately. So now if I want from these, finally, if I want from these lists of strings get the numbers, I can translate it into float. So what I need to do, in fact, after splitting the line, I can do, I don't know, x equals float, and then I take my variable and I take my first element of this variable and I say this is x. Remember, these are, as I said, these are the 3 points with x, y, z coordinates, right? And then I'll copy and paste it. So I'll do the same for y is a float of split line 1, and I do the same for z. And then, well, I can print my x, y, and z, and let's see what I have. So now these strings turned into floats, turned into numbers. And finally, if I wanted, in fact, to have this appended to the data and then have an array of data, I need to do the following. I need data append, right? I'm appending to a list, and I'm appending to a list x, y, and z. And I can print my data so that you see what my data looks like. Okay. All right. So we read the data from the file, we split it, we parsed it. This is called parsing, and this is something you very frequently need to do. We ignore all the comments, and then we printed the data, and we also wrote it into the into these list. And I think with that, I would like to conclude today. So if you have any questions, it's a good time to ask. I'll stop recording, and you can ask me questions.